So girls, the next exercise is all about finding the gradient of a line. Okay, so for example, in question 2b, they've given you these 2 points, okay, 2 coordinates, okay? What they want you to do, if I link this up visually, that's off. But you get the point. They want you to find the steepness or the gradient of that line. So the gradient or the steepness of the line is measured based on comparing how high and how far the line goes, or in other words, rise of a run. So if you recall, the formula to calculate the gradient is this. Okay? So the top gives you the rise, how far up, and the formula at the bottom gives you how far the line comes out. So let's label the coordinates, but like I said from yesterday, it doesn't matter which one you label x1, y1. Okay? So let's call that x1, y1, and this one I've got x2, y2. All you need to do now is just plug in the formula. So if I do that, my y2 is minus 7, minus my y1 is 3, x2 is minus 2, minus, what's my next one? 3. Okay? So basically if you put that in the calculator, you're going to get minus 10 over minus 5, which is 2. So that means the gradient is 2 for this line. Okay? Let's have a look at question 4 now. Okay?
Sir?
Yeah.
Does it matter which one you label as x2 and y2?
Like I said, no, it doesn't.
Okay.
Yep, you'll get the same answer. If you look at question 4, what I'm going to do now is label those 4 points. Okay? So girls, having a look. All right, so question 4, it says the points, these coordinates which are there, form a quadrilateral. So what they mean by that is if I link this up, I get a quadrilateral which looks like a parallelogram. Yep. Now, what they want you to do in question 4a is find the gradients of, let me label the points. This is A, what's my B? 4, 11. C is 12 and 15, and D. So for question 4a, what they want you to do is find the gradients of AB and DC. So let's label this x1, y1, all right, and x2, y2. So what we're going to do is calculate the gradient of those two. All right, what comes first? y2 minus y1 is 11 minus 5, and the bottom is 4 minus 2, so this is 3. That's right. Now we're going to do the same thing for what's the other gradient they want you to find? DC. So let's, that one in purple. So let's call this one x1, y1 and x2, y2. So the gradient of DC, once again, y2 minus y1 in this case is 15 minus 9 and 12 minus 10. And what's that? 3. So girls, if you get the same gradient number for the two lines, okay, that means they have the same gradient, which means they're actually parallel to each other. Okay, so that's what that means. It says, the next question, it says show that AB is parallel to DC. We can say therefore it is parallel because they have the same gradient. Okay, question 4b. They want you to do the same thing. Girls, I'm not going to go through it because it's the same thing. But if you look at question 4b, find the gradients of BC and then find the gradient of AD. And once again, girls, you should get the same number when you find the gradient of those two lines. Okay? Which proves that the two lines are what? Parallel to each other. So girls, now can you see, after I've done question 4D, have a look at question 4C, girls. What type of quadrilateral is ABCD? Okay? Now, girls, if this was an exam question, you can't just say it's a parallelogram. You need to give a reason why. And what's the property that proves that's a parallelogram?
Two parallel sides.
Yeah, opposite sides or two pairs of opposite sides are parallel. So girls, we've got those 4 points. Okay, let's join it up. As you can see, it looks like a square. Okay, let me label the sides. So this is A. All right, question 9a. Girls, show that the opposite sides are parallel and hence that ABCD is a parallelogram. It looks like a square, but they want you to prove that this is a parallelogram. What do you think they're saying that?
Because they're parallel lines.
Square has all the properties of a rectangle. Square also has all the properties of a parallelogram. Okay? So when they say prove that this is a parallelogram, what they're trying to say is prove that this square right now has a property of a parallelogram, which in this case, they're asking you to do what? Show that opposite sides are parallel. So all they want you to do is exactly what I've shown you before. Find the gradient of that, compare it with which line? AD, and then do the other way as well. Find the gradient of that, and then find the gradient of that, and prove those two parallels are the same. Yep, so I'm going to skip 9A because I've shown you how to do it. Show that AB, so this line here, is perpendicular to BC. Okay, so that's what it means. If it says prove that AB, this symbol means perpendicular to BC. So we need to prove that this line is perpendicular to that. Now, if you recall, okay, you know what? Without me explaining, let's just find the gradient. That's what you want to do. Let's find the gradient of AB. Okay? So once again, let's label the sides. So x1, y1, x2, y2. Help me out here. What am I writing? -1, -1. And 3, what? -1. Yep. So that's -2/4. So that's -1/2. Okay, so that's the gradient of AB. Now let's find the gradient of BC. Okay, so I'm going to, okay, you know what? I'm going to now call this one x1, y1. Okay, like I said, it doesn't matter which order you write x1, y1. Okay, so let's find the gradient of BC. Okay, using what I labeled. So y2 minus y1 in this case is -1, -3. And what's that? -4 over -2, which is? Yeah, minus becomes plus. Now, technically 2 is the same thing as 2 over 1, yeah? If you flip the fraction around and put a negative sign in front of it, if you get that, that means they're perpendicular to each other. The technical rule is reciprocate fraction and put minus sign, okay? If you reciprocate the fraction and put a minus sign and that's the same number for the other one as well, it means they're perpendicular. So for another example, let's say my gradient was 3/4. If I want to know the gradient that will give me perpendicular to that, what would the fraction be? -4/3. Yeah? Another example, just to make sure. Let's say I had -6, which is the same thing as -6/1. If I wanted to know the perpendicular gradient to that, it would be 1/6. Not a minus in front, because right now I have a minus. If you put another minus, it becomes plus. So that's the rule. If you want to prove something is perpendicular to another, reciprocate, put a minus. All right? And that proves it's a rectangle. In this case, it's just saying, remember, rectangle has all right angle inside the quadrilateral. Okay? So we've just proven a property of a rectangle by proving that the lines form a right angle. Yeah? You guys with me so far? No, in this case, just for that. That's enough. Okay? 9C. Show that, you guys reading with me? Show that AB, this line, is equal to BC. What does that mean? It says to prove AC equals to BC. How do we prove that? What's AC?
It's AB.
Oh, sorry, AB, that's right, yeah. AB. We did this yesterday. Yeah, find the distance of AB, okay? You'll get some number. Find the distance of BC, you'll get some number, and what you'll find, girls, what do you think you'll get? The same number. Okay? And that proves it's a square, because with a square, all sides are equal. Okay? Do I need to go through that distance part? Yeah. All right? So, girls, that's what you need to do. I'll stop here. There are a couple more questions that I want to go through later on, but that should get you through the first few exercises. Okay?